Okay, let's go. So thanks again. Thanks for coming. Good morning, good afternoon, good evening, wherever you might be. We're going to talk about containers and specifically about why we as developers need to care about security when it comes to containers. A little bit about myself so you know where I'm coming from. Again, my name's Eric Smalling. I'm in the Dallas-Fort Worth area, and I have been a developer advocate with Sneak for about a year and a half. We are a developer-focused security vulnerability scanning company, and I'm not really going to talk about our stuff today. That's not important. So you know where I'm coming from, I have a developer background. So I was a enterprise software developer for about 20 years here in the North Texas area, and primarily C, C++, and then turned to Java for the majority of my time doing that. And then I started getting into consulting around what we would now call the DevOps space, you know, build automation, test automation, and been doing that for about a decade before I started at Sneak. I have been using containers and specifically Docker since the early days, back in 2013 when we discovered it at the place I was at, version .6, which was quite the wild, wild west back then. We didn't have orchestrators, didn't even have Compose back then. But I have been at one time a Jenkins ambassador, so I am pretty versed in the CI/CD space. I've used many other systems, of course, but as of last year, I became a Docker captain, and I'm also certified in the 3 main Kubernetes certifications. So hopefully I'll be able to answer any questions. If you care to follow me on socials, there's my info at the bottom there. But that all behind us, here's what we're going to cover today. First, we're going to talk about DevOps at a high level and how security applies to it. But then we're going to get to the meat of the conversation, which is, as developers, what are the challenges we face when we containerize our apps? I'll try to stay clear of slides as much as I can and get right into the demo as fast as I can. I do understand that you out there may have a different, very wide level of experience around containers. This isn't going to be a Docker 101, but I will try to, talk to it so people who are new to containers won't get lost. We'll have Q&A throughout, and then after the talk, obviously, there's the face-to-face section afterwards. So if you have questions, feel free to put them in the chat, and we'll get to them as we can. And anyway, so let's get started. So DevOps. DevOps is kind of a loaded term for some people. It's kind of one of these things, kind of like Agile, where unfortunately it turned into a product for a lot of consultancies and other vendors and things. But really, when I say DevOps, I want you to understand I'm talking about the paradigm, the whole idea of development, developers, and operations working together. And it includes more than just your standard sysadmins and developers and SREs and everything. It's QA. It's all the other pieces kind of packaged into one thing, and that includes security. We often think about DevOps around our software delivery lifecycle, and this is a very simplistic diagram showing from ideation to production. You're coding on the left and moving through some very general stages till we get to production on the right. And the little sneak are my company's logo patched. His name's Patch, by the way. Those logos are kind of indicative of where security historically gets applied. We've always had security in production. That's kind of table stakes, right? You've got firewalls around things. You've got tripwire, role-based access control, intrusion detection, all the things that we always have had around our systems. As security started to become part of the CD world, we often would see it in a late stage in these pipelines. Usually, honestly, because the security team had to do it manually. They would do audits, and you couldn't do it as fast as you might be building and doing your smoke tests and things. So they would wait until the product was right about to go to production or maybe staging. Functional testing was pretty much done, and they would do their audit and make sure that there wasn't anything being introduced in the release that's problematic. Unfortunately, if there was something problematic, because it's late stage like that, that's one of those situations where you're pulling the cord on the assembly line and stopping everything and causing developers to have to reset and figure out what exactly did we do, what did we add, how do we figure this out, what is the problem, which is half the challenge. Automation was added here historically, but oftentimes legacy security automation either was very slow and took like hours or overnight to run, or maybe had very onerous licensing or hardware requirements where you could only run it on a few of your CI build agents or something. So again, it was put at that late stage. As things have matured, we've seen it security shifting left. You'll hear that term a lot, shifting left on a pipeline. And we started to see, especially in the container space, we started to see vulnerability scanning happening at the registry. So when you push a new image into a registry, and the image is the basis for what a container runs on, scanning could happen at that time. And if there was any vulnerabilities found, a report kind of list would be sent to you, and you'd have to, oh, shoot, you got to figure out what's going on. Or maybe even in the code repositories themselves, as a change happens on your master main branch, your CI server could be doing a scan as that happens. Move forward, we started seeing these things started to get fast enough where you could actually use it as part of, say, a pull request automated review, or a pre-merge step, to where before it even gets into your branch or your main line, those tests could be run. But the holy grail is to get this kind of testing all the way to the most as far left on the pipeline as you can get, and that would be my workstation. As I'm working, I want something that I can be alerted to problems as I typed my code, or as I updated my Docker file, or as I set up my Kubernetes manifest, or whatever. And that's kind of where you want to aim for process-wise, is try to find tools. Now, obviously, I'm biased to a particular vendor, but look for tools where your developers can look at that, or you as a developer can look and get results fast right on your workstation, so that before you even make a commit, that there might be an issue. And when you look at tools, make sure that they're giving you proactive, actionable information, so that it's not just a spreadsheet of errors and like, oh, well, what do I do with this? That being said, what I've been describing is what we call DevSecOps. It is moving security left. This is really, there's some controversy about this term. Is there really a thing called DevSecOps? And honestly, it should be part of DevOps. When we say DevSecOps, we're really just saying it to make sure you remember security needs to be here. Now, the fact that security was so far down the pipeline is not really security's fault. When we had our big DevOps party of the last decade, we kind of forgot to invite security to the party in many cases. And now we've found how important it is, especially with all the vulnerabilities that have been hitting us over the last couple of years, and with supply chain attacks and whatnot. That security really needs to be one of these things you tackle right up front as you're developing. So all that aside, let's talk about containers and specifically here, and what are these challenges? The first of them, really, and the overarching thing, is that as a developer, I know historically I own my code. I own what third-party libraries I'm importing to it, or at least my architects do. And we understand we need to write clean code. We need to use well-maintained and patched libraries, modules, whatever, depending on how you're doing your code. And obviously, there are ways to scan those things, and you want to make sure that what you're doing is good. But what containers is adding to us now is the scope of the operating system level concerns. Things like the base image. So a container is the image that you build upon to run a container. Starts from a base, and that is kind of like almost like an empty virtual machine. It's not like a virtual machine, but you want to know, when you're choosing that base image, what am I choosing? What distribution of Linux is it being used? Is this something that we have expertise in? Do I care? All of those kinds of questions come up. And what packages might I be installing on top of that my application needs or doesn't need? How do I putting it all together? What are the permissions, whether they be file-based, file per system permissions, user ID, all of those things start coming up. And we very often don't have a lot of expertise in the development community around these things historically. We may have built Linux boxes ourselves, so we understand bits and pieces of it, but honestly, we usually are handed these things. we historically have been given a machine, whether it be a physical or virtual server. It's already been set up. Security has already set up the file system permissions the users were supposed to use. If it applies, you might have a middleware team that owns that. And we haven't had to think too much about it. We understand it. We know it's there, but we've kind of gotten our hands held a little bit. Well, now that Dockerfiles, which are the kind of the blueprint for building an image, and infrastructure as code manifests and things like that are starting to appear, they're getting dropped as code right alongside our application code. And while we still have experts in those fields to work with us usually, we still could very easily make a mistake. And if you open up, all of a sudden you're running as a user that has too many privileges, or you mount a file system that you shouldn't be mounting, you need to be cognizant that that can happen. And then finally, the whole point of DevOps and Agile really was to get from ideation to production as fast as possible, that time to market. And as we start to think about adding security concerns and scanning and all these other process to the developer's workload, we can't do it in a way that's going to really slow down velocity. In fact, business would like us to increase velocity at all times, right? So you need to think about that as it applies to containers. So when I talk about applications and we think about what is it that an application or a service, we might call it, contains, we know about source code. As I said, you've got your code, you need to be writing good code, not doing bad practice, sanitize your inputs, do all things like that. And we know that our third-party dependencies matter as far as picking ones that are vetted, that don't have vulnerabilities in them, or if they do, keeping on top and getting updates for those. But these containers, as I said, add operating system type things. Now, this is a quick snippet of example of a Dockerfile that's based on Python 3. Well, which build of Python 3? Which major minor version? Well, it's major 3, but which minor patch version of that? What base is it? A Debian base? Is it an Alpine? What is it? From that, we really don't know based on this. And what is the stress ng package? I don't know what version I'm getting installed now. Why do I need it? Do I need it? All those questions are the kinds of things I'm talking about. Then, of course, on top of that, we've got our infrastructure as code, which is coming in now. You might have Terraform as this shows, or CloudFormation, or you name it. Files getting added, and then the granddaddy of them all for containers is, in most places, Kubernetes, which is an API that is constantly getting updated at three releases a year now, which is better than 4, I guess. But and there are just so many things that you could do right and wrong if you're not, staying on top of it. It's enough to get your application working on top of this, but you can start hyperventilating trying to make sure it's secure. I throw this example up, not because I'm trying to single out Capital One. I actually have friends that work at Capital One, and they are an excellent shop, very good open source supporters. But I bring them up because they are, they had a security breach that was well known, and I think it's a good example of what the things that we need to think about here. A few years ago, they had they were impacted, about 100 million users in the United States. And then this situation, I'll call it, caused them to, depending on who you read, they cost them like between 100 and 150 million dollars, both in fines and lost revenue and whatnot. The reason I bring it up is because it's a good example of how misconfiguration in configuration as code type things can be catastrophic if you do it wrong. And there's a lot of factors that happen here. I can't, in a minute here, I can't really describe the whole problem, but there were things like permissions issues with RBAC. There were misconfigurations in web application firewalls, exploitable vulnerabilities. And there was kind of this perfect storm that hit that the real takeaway is that these giant distributed applications have such an increasing set of complexability scope that no one person really knows everything about it. In often cases, the systems you're configuring to aren't even yours. They may be cloud-based systems that you are just trusting work. And taken as a whole, this whole thing, what I'm trying to get across is that it's hard to know how it's all glued together. And can make it easy in a perfect storm kind of a situation like they had for this kind of a thing to happen. And if you want to know more about this, my slides, I'll give you the link to my slides at the end. You can click the article there and read more about exactly what happened. But if it can happen to them, it can happen to any of us, is my point. So enough of these slides. Actually, I have one more slide, but let's talk about this demonstration I'll show you. Now, I've written a quick little application, and no judging my Python skills. I'm a middling Python coder at best. But I just wanted to show an example. There was a remote code execution exploit, vulnerability, excuse me, in the Celery framework. It's been fixed. So if you're on the latest version of Celery, you're good. But I wanted to show you an example of how it could, what it looks like for an RCE, as we say, to be exploited. The application we're going to be looking at is a simple web app that has a bottle front end, uses Celery to store information, and I'm using a MongoDB backend. A Celery worker picks up and Celery is a task queuing kind of a messaging system, sort of. And the Celery worker will pick up a message from the web app to translate a piece of text, and it'll do the translation and update the MongoDB record accordingly, and you'll get your translated text. These kinds of systems are often used when you have jobs that might take longer and you don't want it to be synchronous, so you want an async task, which is exactly what this is. So let me get out of the slides here and we'll take a look what we got. So my app is the Chefalizer, and what this app does, let me copy something from my other monitor into here. I'm going to copy the good old Agile manifesto into this, and I'm going to submit it. Now, what has happened on the back end, and actually, let me get my logs going over here so we can see the web app logs, is it took that text and it applied the Muppets Swedish Chef algorithm to it and translated it to Swedish Chef. And for those of you who don't know who the Muppets are, you're probably really wondering what the heck that is. But so you can see it now says Manifesto for Agile software development. And okay, it's silly, but what happened here is that got put into MongoDB. The Celery worker saw that, picked it up, translated it, put it back, and then we're displaying it. Now, if we go back in here, and I'll just put another thing here, let's say hello Python web conf. We'll submit that, and we've got another one. Now, at some point in development, we realized that, hey, that we needed this list here, this completed chefalizations, of those I'm calling it, list. And being the middling Python programmer and not a Celery expert, I couldn't figure out a good way to do that using the Celery APIs. Because right now, Celery is the kind of the interface to Mongo in both cases. But I figured out that, hey, I could just connect directly to the Mongo database and get that information out. And so that's what I'm doing. That's how this list is being formed. I'm just saying, hey, Mongo, give me all the documents that match the criteria that I need for these. I get my list. Now, I also, customers said, hey, I would really like to be able to edit these translations after they're made so that, like, for instance, we'll open this one and we'll remove a couple new lines here and we'll hit submit. So that cleaned that up a little bit, less new lines in there. And what we've done there, again, is because we don't want to retranslate it after that. We just want to take the changes. So I just updated the document in Mongo. Well, let me switch roles here to the hacker role, the black hat, for a second. And let's say that I'm looking at industry blogs and whatnot, and I find out your company is a Celery user. And I know that Celery had an RCE vulnerability recently. And I'm thinking, maybe you might be on an older version of Celery. Through whatever means, and again, this is a very contrived example, just for the point of the demo. Let's say I came in here and I edited this, but instead of putting text in here, I put in a JSON snippet. And this is a piece in here. And the thing I want you to pay attention to here is the end of it where it says ENV in those quotes. I'm going to submit this. And you can see it, you see on the right, I've had the logs for the application, the web app being tailed. Now I'm going to edit this. Now, when I click edit, the application is going to use Celery to read that task, that async task, back in. When that happens, now we get crap, we get junk over here in the web app, but I'm pointing at my monitor like you can see it, sorry. But in the logs, notice this. This is that env happening in my web server. And that is the environment of the process that's running my Python app, my bottle-based, web app. That by itself is not, great for a hacker because they're not seeing that. However, there are other things they can do. Let me go back here, go back a page. And I'm just going to add another entry. And sorry, I might copy another piece of text here. I'm going to do basically the same thing, but I'm going to change this now to do a curl. I'm going to curl. I'm just using google.com for fun. And oops, I don't want to translate. It translated that. That's not what I wanted. Let me make a, actually, I did make, let me edit this record. Sorry. It's on the edit that this happens. So now let's clear my screen so we can see this better. Of course. We'll pull that up again and you can see that curl happened. Now, again, I'm hitting Google, which is irrelevant. More likely, I would have hit my own server and I would have seen information back about more about where this came from. More likely than that, I probably would have curled down a script that starts trying to build a beachhead in this server, whether it's in a container or not, it doesn't matter. The very likely that script would have started Bitcoin mining or something, or it would have started poking around the network and looking for what else is running on here. One really nasty thing I could do, go back here and we'll make another record and edit it. Now I'm doing something really nasty. I'm doing an install and I'm running, installing something called Teammate. Teammate is a tmux, kind of like a paired programming type of a tool, starts up a remote connectable shell. And if I edit that, oops, I will do this right one of these times, sorry. Submit, live demos, always fun. Edit, submit, edit. Of course, when you do live demos, it always doesn't want to happen. Excuse me for just a second. What am I doing wrong? Okay, edit. Submit. Of course, so live demos are always fun. Oh, I know what I'm doing wrong. Sorry about this. Give me just a second. I have implemented it. I forgot I was testing this out beforehand and I made a change. Ignore the man behind the curtain. Sorry about that. You're seeing an end state, not the actual where I was supposed to be in this part of the demo. Let me clear this out. This is why people often record their demos. But I like running live. So fun times. Okay, we're reset back to where I meant to be. And we'll just make a record. My newly cleaned server, edit that, submit, get my logs going here again. There we go. Okay. So as I wanted to show you, so you see apt-get happening back there and a bunch of stuff just ran. It installed a package that if I now, let's say, come over here, I am SSH'd into that shell. So if I do hostname, add it, you can see it from the prompt, that's my container. I can move around in here. I can look at my password file. Now I am in a container, but as you saw, I can apt-get, I can curl things. Let's see if I can actually get run 301. That's 301 is still a valid chance or thing. I can do whatever I want. Now I'm going to kill this because there are those out there who probably saw that SSH and probably are trying to get into my app now as it is. But you can see how bad it can get. In a real world scenario, I would have had my own teammate server running and not, hitting a public one. And I would have seen the connection come in and say, hey, I got one. And I would have started doing my thing. Or as I said, I would just have a script that starts doing nefarious things to that host. So what we saw was on reading that Celery vulnerability was triggered and it executed whatever I wanted it to on that server. Again, this is a very contrived example, but what we see here is a combination of two things: an injection problem that somebody added to their code, and then the exploitation of a vulnerability on top of that to create a security incident. While, as I said earlier, you want to be scanning your code and your modules so you would know if there's a Celery vulnerability here, what I want to talk to you about here is the container aspect of this. And what can we do as container engineers to mitigate some of this and avoid some of this? So we pop over to here. There are some things you can do that kind of fall under the defense in depth area to limit blast radius, honestly. What you're trying to do is if something comes up, and I say that because the Celery issue is one that we know. It's what you don't know that you don't know that's usually the problem in security. The 0 day. Our Java colleagues found this out with Log4j back around Christmas time. When there's a 0 day that is a remote code execution type and it's easy to exploit that magic combo, you want to make sure that what you're doing at least makes it life hard for the hacker to utilize and expand, set up a beachhead inside your servers. The first thing you can do the first things you can do are related to building of images. Now, as I mentioned, if you're new to Docker, an image is kind of the basis for a container. It is the file system and metadata that the container runtime engine uses to start a container. And you want to minimize the footprint or the file system size of that image, not just for performance reasons, for copying that image around your data center, but because you don't want to have files in there that you don't want to give the tools to the hacker to use against you. I attended a meetup recently where there was a bunch of penetration testing, and they call it living off the land. If when I'm on a machine or my script is running on somebody's machine, I want to make sure I'm using their tools against them rather than bringing in new ones, because that's going to trip firewalls often, or I'm sorry, tripwires often, and intrusion detection and whatnot. So if you're giving the hacker tools, and in this case, we saw a few things that I gave to the hacker, if you will. Because I used that Python 3, in fact, I didn't show you the Docker file. Let me show you what it looks like. I'll scroll up, I've got it right here. This is the Docker file we were running, and it starts from Python 3.9.9. That image is what I call a general image. It's an official open source image. But there are many versions of these images, and that one just basically says, hey, this is 3.9.9, but that means those images have a lot of stuff in them. If I were to pull Docker, you can see that there's 2 Docker images there. 3.9.9 has 860 megabytes of content. That's because it has everything. It's meant to be a general use image for developers, anybody to play with Python, to get things running. It has all the things you might need, the kitchen sink, if you will. There's another image you see here called the same thing, -slim. The slim versions of images, these are the tags that are versions. These are meant to be just what you need to run Python 3.9.9. They may not have everything you need. You might have to add some packages to them if you've got some specialized things like database drivers or whatnot. But you can notice the difference. This is only 115 megabyte. And I guarantee you, if we were to redo this and rebuild this with that version, it's not going to have curl. And that's like the first thing that curl or wget that I'm going to look for as a hacker to get things and start pulling things down to this image to use against you. There are other versions of these things. There's the Google has distroless images, which are even smaller. There are Alpine-based images, but you can see that you start having to deal with, okay, well, what am I going to use? What's the right thing to use? We'll talk more about that in a minute. But this kind of also adds to the conversation about how our image is built, and I call this layer housekeeping. So images are layered. Each line in that Docker file you saw starts from a base, and then we do something to add a package, or we do something to add our code to it, and then whatnot. Each layer is put together at runtime to form a unified, it's a layered file system, and it presents that to the process as a single file system. As it starts up by default, well, I'll get to that in a second. As it starts up, let's say I didn't want to have curl in there, but I wanted to keep that big base image for whatever reason. I could do a run remove curl from in the Docker file and remove it if I wasn't aware of how this worked. Unfortunately, much like a Git type version control system, if I were to add curl in a commit it to Git, and then remove it in a later commit, it's still there in the repository. It's just being held by, or excuse me, hidden by the later revision. Same here. If you remove it in a layer, it's still there, just hidden. And if there were if somebody accidentally mounted the host's var file system, for instance, on a default setup with containerd or Docker or cryo, whatever, a bad actor finding that poorly done mount could find that curl in the history, because those layers will still all be there. Better is to start with an image that doesn't have it. That way you're not worried about having to remove things or whether they really got removed or not. Which kind of moves me on to build strategies. So as you're building your images, there are many different strategies you can use to minimize that size and to do the right things. Docker implemented something called multi-stage builds in 2017. This allows you to have multiple chunks or sections or stages in your Docker file. Each one starts with one of those from lines. You start from Python, we'll say, you do all your work to get your application ready to go. Then you can have another from line that's say Nginx or some other web server. And then you just copy the bits from the prior stage into that final one, and you end up with this nice tiny image that only has the bits you need at runtime. It doesn't have your build system. It doesn't have things that you don't need. Another piece of your build strategy you want to pay attention to is, are your builds repeatable? So for a given commit, can I build an image from that again dependably, deterministically? And by using an image like Python 3.9.9, whether it's the slim version or not, you're pretty guaranteed you're going to get that same base image each time you do it. However, there are, like I showed on that slide earlier, there are images that are tagged Python 3 or 3.9 even. Those are moving. Those are mutatable tags that will always be, well, by convention, will always be pointing at the latest build of the Python 3 or 3.9 or whatever. They're going to move. Now, there are varying opinions on this, but if you want fully deterministic builds, you use the most specific tag you can. In fact, you can actually put the SHA hash of the manifest on that from line, and you're guaranteed you're always going to get the same base image. Kind of brittle, but you can do that. Other camps, if you're in a very high velocity CD type thing, you might want to always have the latest one without having to change it. So you use the lesser specific 3, and you'll always be on the latest Python 3 every time you do a build. So you got that trade-off you have to think about as you do that. If you are going to use the specific one, which I'm a fan of, you do need to have a process in place for scanning those images, whether it's with our tool or some other kind of container scanner, that will let you know when vulnerabilities are found in an image, and then you need to react to that and update the image to move to the next version that has the vulnerabilities fixed in it. There are other two things you can do, like Docker labels, where you can apply manifests, metadata to your images, things that aren't used by the runtime, but are more interesting from an image point of view. So a common one is to add, where is the Git repository for the image that, for the image you're looking at, what Git repository and commit did it come from? Some people like to put in help stuff in there. You can actually have, say how to run this and a little blurb of text of like a Docker run line or something. And these can be applied using Docker labels or OCI image annotations. And there are other tools for building images. So Docker obviously is the most popular one, but there's things like Builda. If you are in a Red Hat shop, you're probably using Builda if you're doing OpenShift. If other Java users use Jib, Go users use Co often. And there's also Canico. There's a whole bunch of other build tools that may or may not be a good fit for your organization, but it's good to know that they exist. And finally, secure supply chain, there are entire conferences dedicated to secure supply chain. What I'm getting at by mentioning it here is that whatever image you use, whatever base image you choose, whatever image you build, you need to know where it came from and how it got there. Don't just take things randomly off the internet or from your vendor in email or whatever and start using it. It needs to have an audit trail, and especially needs to be, it needs to be put into your image registries, the servers that hold the images, by automation. It shouldn't be Eric building an image on my laptop and I'm pushing it to the server. Now we're just going to use that, because there's no audit trail there. You don't know what I was really doing necessarily. Was my machine infected with malware and there's a supply chain attack happening through my own, you need it to be auditable and automated. Now we'll get into the interesting stuff, and I'll show you some demonstrations of mitigations you can do at runtime. As you saw earlier, I was doing something I was doing one of these already, but that's why the demo failed on me. But first of all, most official open source packages start up as root. The default in Docker when an image is created, if you don't specify otherwise, is to run as the root or UID0 user. And even though you're running in a container, if a hacker gets a remote code execution like I did, just because you're in a container doesn't mean it's safe for them to run as root. As I mentioned earlier, if somebody were to mount a host file system into a container, which you shouldn't be doing bind mounts or host file system mounts because of this, because as soon as a container is running as UID0 in the container, with a couple exceptions, the files that they can see through that mount, they are also root on those files. So if somebody were to share etc into your container and your UID0, you have read-write access to that by default. So let's take a look at how that could help us with the demo we just looked at. So I'm going to go back here. I'm going to edit the Docker Compose file. And if you're not familiar with Docker Compose, this is just a way of specifying, and I have 4 different containers I want to run, or services as they call them. And this is how to run them every time. So it's a way of automating this. Very similar in Kubernetes, you'd have manifests for all these, but I wanted to keep it simple for this demo. So I'm going to say user, I know from looking at the Python default image, they have a nobody user. Many of them do. And if I use that, it will start the process as that user instead of whatever the image said or didn't say to use. You can also edit the Docker file. You can say, hey, when this runs, default it, use this specific user. But I didn't want to rebuild the image for this. So I just started it back up and it's running as the nobody user. And I'm going to start my logs back up over here and get my web app. Let's reload. Of course, that. And if I execute this again, you'll see I'm getting a permission denied as soon as that teammate, as soon as the apt-get install tries to happen, because I'm not root anymore in that container, and nobody is not allowed to run apt-get install. So that right there will make life harder for that class of attack. And all you have to do is specify a user. Most business applications don't need to run as root, so that's a good one, I think, to do. I know I'm running low on time, so I'm going to quickly go through a few of these. Privileged containers, you don't ever want to use. Unless you're writing really low-level monitoring things for your clusters, you don't need privilege. That gives you basically access to the devices on the host outside the container. You don't need that. Linux capabilities, these are processes that make system calls. This is more used by C programmers or Go or Rust programmers who are doing system level kinds of things, or if your process happens to need to do something that's a little bit outside the norms, a little bit more higher security, the Linux kernel provides these system capabilities that you can limit by basically dropping them. And I recommend for business applications, or just about most applications that people are writing, they're attending my talks, you probably don't need any of them. You can drop them all. And there's arguments you can look at in both Kubernetes and Docker to do that. The read-only root file system, this is what you saw earlier. I couldn't run my demo earlier because I had forgotten. I had been doing my testing and forgot to take that back out of my compose file. And by adding read-only true to my compose file for that container, what it did is, as the container started up, it couldn't, it mounted it read-only, mounted the root file system read-only. It didn't put the read-write layer in there. So apt-get couldn't do its thing. Even if I am root, it can't modify the file system to install anything. This one is even more effective against trying to curl a script down and make a change. It's also effective against people trying to change your application or your templates as part of their exploitation. It also promotes 12-factor immutable apps. So if you can run read-only, you should. It helps with a lot. And then finally, again, deploy known sources. Don't be pulling images from crazy places. Finally, if you are on Kubernetes, if you have credentials, use secrets. Use Kubernetes secrets. If you're not already using something like HashiCorp Vault or some other kind of secret management system, Kubernetes secrets are great. If you're using them, make sure you're protecting them with role-based access control, and make sure that your cluster operators are encrypting your secrets at rest, because by default they're not if they're rolling their own Kubernetes clusters. You should use role-based access control in general. It's just good. And security context, this is the API to do a lot of what I just showed you on the runtime slide. There's a lot of things you can do here to restrict the containers and the pods that run them, and don't have time to run through this all. But that's where you would apply most of those things. Network policy is a very important thing to understand. And developers, we often think network firewalls, it's crazy, I don't want to deal with that. But it's really not that bad. Just all it is saying, hey, pods, what can they talk to and what can't they? I'm a fan of starting up with a zero trust policy where pods cannot talk to each other unless I explicitly allow them to. And it's done on a label basis. Let you research that on your own. And finally, enforce all of these things with a tool like OPA Gatekeeper or Kyverno or other tools similar to those that will enforce policies like all of these things on the users of the cluster. Don't have time to go through that slide because I'm running out of time. This slide has a lot of good information. Again, I will post to my socials where these slides can be. I don't know if the conference will have them as well, but if you follow at Eric Smalling on Twitter, this will be posted moments after I'm done here. Notably on this, that Python, if you're interested in that Celery RCE, we have a case study that one of my colleagues did on it, as well as a video about it that are linked here, and a lot of other good stuff. And with that, I think I have like a minute and a half left. Do we have any questions? Wow.
I put in a question. So since I'm moderating a track, I get to ask my own question.
Go for it.
For local development, changing into an alternate user ID can be tricky when you're doing bind mounts into the container and you get different behaviors between Mac and Linux. Is there a global one way to solve that problem so that it's easy to develop as a developer, but then when we push it into CI, we build with an alternate user?
Yeah, so oftentimes we'll see that when people are trying to bind mount in, so that as you're editing your code locally in your IDE, the change immediately happens in the long-term running container, and that is troubling. It's problematic sometimes, and I wish I had a good answer for you on that one. It is the one case, honestly, where I will say, okay, you know what, you can run as root if you're local. Gosh, we just don't have time to get into the minutia of it.
Maybe folks can ask that over in the
and I'll look up. There's a couple articles I think I'm trying to remember on that I could post also.
Yeah, if you can post those, that'd be great. I am eternally searching for like the smoothest, easiest way to do that. But